multiple spanning tree topology, layer 2 switch on BIRR, I need 6 interfaces for trunks. I will add 7. Okay, between DLS1 and DLS2, 11 and 12, ALS1 and ALS2, 11 and 12, connect tool, I will use 1, 1 and 1, 2. Nine and 10 between DLS1 and ALS2, and 9 and 10 between DLS2 and ALS1. I will use 0, 3 and 1, 0. 0, 3 and 1, 0. 7 and 8, 7 and 8. We'll use 0, 1 and 0, 2. Okay, launch simulation. Yes. Prepare the switches for the lab. Use the reset.tcl script you created in lab 1, preparing the switch, to set your switches up for this lab. Then load the file base.cfg into the running config with the command copy /base.cfg to running config. This is the example for DLS1. Run the script using the TCL shell and copy the base.cfg file to the running config. Okay, this is a script to erase the device, and this is another script to configure the basic settings. For basic settings, this is the script, the base.cfg file. You can run this script, or simply you can copy and paste these commands from the notepad. Set the IP domain name, disable the domain lookup, shut down all interfaces on your device. In my case, gigabit 00, 01, 02, and 03, and gigabit 10, 11, 12, and 13. Shut down all interfaces. Okay, this is the range of interfaces. There is a gigabit 00 here, but it's not shown, but exists. Set the BTP mode transparent, configure the line console with no exit timeout and login synchronous, very useful to configure devices, and set the host name. But before to apply the basic settings, you need to erase and reload the layer 3 switch. This is the script for the layer 3 switch, or simply copy and paste these commands from Notepad. erase the startup config and delete the files, and set the SDN prefer. BIRL does not support this command. Okay, then reload the switch. This will be applied only on a real lab switch. To set the SDN prefer on a layer 3 switch, for example 3560 switch, using the SDN prefer to dual IPv4 and IPv6 routing. This is the script for the erase and reload the layer 2 switch, or you can use these commands to copy and paste from a notepad. Erase the startup config, delete files, set the SDN prefer on a layer 2 switch to LAN-based routing. For example, on a layer 2 switch 2960. Finally, reload the switch. Okay. So, first of all, apply this command on all devices, but remove the SDN prefer. Okay, apply this on all my devices. DLS1, enable, paste. Okay, DLS2, enable, paste. DLS1, enter, enable, paste. ALS2, enable, paste. Okay, on DLS1, and now apply the basic settings. On DLS1, for example, enter, enable, configure terminal. Okay, DLS1, DLS2, enter, enable, configure terminal. DLS2, ALS1, enter, enable, configure terminal, paste. ALS1, ALS2, enable, configure terminal, paste. ALS2, configure trunking. Let's configure interfaces 7 to 12 as AO2.1Q trunk ports on all 4 switches. Additionally, configure all 4 switches BTP servers. Okay, BTP mode server, and configure trunks. Okay, from 7 to 12 in all switches. All used interfaces are trunks. Okay, in my case, gigabit 01, 02, 03, 10, 11, and 12. Gigabit 13 is not in use. Okay, this was previously configured in another labs on previous labs. So I will copy and paste this, set the BTP mode to server, the range of interfaces, the encapsulation .1q, the native VLAN 666, allow all VLANs except 1 and 999, the mode trunk, non negotiate, and enable interface with the not shutdown command, then exit. These are the commands. Copy. Okay, look at this. My range is different. Gigabit 01 to 03 and 10 to 12. Gigabit 01 to 03, gigabit 10 to 12. Okay, on DLS1, don't forget to set the BTP mode server and paste BTP mode server, paste BTP mode server, paste BTP mode server, paste. Configure BTP and VLANs. To simplify the lab configuration, configure BTP version 2 on DLS1 with no password, and configure VLANs for use in the network. This configuration will propagate to the other switches in the network. Okay, only on DLS1 configure the BTP domain, the version 2, and the VLANs. DLS1 set the BTP domain to switch lab, the BTP version number 2, VLAN 99 name management, VLAN 100 name servers, VLAN 110 name guest, VLAN 120 name office, VLAN 999 name parking lot. This state suspend. Okay. VLAN 666 name native do not use. Finally, exit to apply changes on VLANs. Okay, BTP domain, BTP version 2, and the VLANs. Okay, verify and show VLAN brief. Okay, our VLANs show BTP status. BTP version 2, domain, no password, on DLS2, and show VLAN brief. Okay, the VLANs were propagated, show BTP status. Also, the version and the domain name were propagated on BTP. Okay, ALS1 show VLAN brief, okay, show BTP status, very nice, ILS2, and show VLAN brief. Okay, very good. Implement multiple spanning tree. In this step, you will implement MST on DLS1 and DLS2. We will ignore ALS1 and ALS2 for now. Issue the global configuration command spanning tree mode MST, and then the privilege exit command clear spanning tree detected protocols. Okay, on DLS1 and DLS2. Configure terminal spanning tree mode MST. And clear spanning tree detected protocols. Verify show spanning tree. Okay, MST. Okay, running MST protocol. DLS2, same way. Configure terminal spanning tree mode MST. Exit. Clear spanning tree detected protocols. Verify show spanning tree MST. Very nice. Observe the default MST configuration. At this point, MST is running with default parameters. On DLS1, issue the show spanning tree MST configuration to see the configuration information. Okay, for example, on DLS1, show spanning tree MST configuration. Okay, now region name, revision 0, only one instance configured, instance number 0, and the VLANs mapped, all VLANs from 1 to 4084. Okay, region named, revision 0, only one instance, the 0 including all VLANs. For MST to work, the region must be named and given a revision number. The revision number does not work like BTP. It is just an administrator assigned by Liu. All the switches in the same region must have the same region name and revision number, and have the same VLAN to instance mapping. Okay, manually configure MST. On DLS1 and DLS2, configure MST. Region name CCNP revision number 1 and VLAN mappings for the instance number 1, VLAN 99 and VLAN 100. MST region configuration is performed in a special mode under the global configuration that is entered using the spanning tree MST configuration command. You have to make the changes and exit from configuration mode to have the changes applied. The changes are not applied until you exit. While in MST configuration mode, you can use the show current and show pending commands to see how the configuration stands. For example, this is for DLS1. Okay, DLS1. Configure terminal, spanning tree, MST configuration. Set the name CCNP uppercase, the region name, the revision set to 1, create a new instance, number 1, and include VLAN 99 and 100. Show the current configuration. Okay, no region name, revision 0, only one instance, including all the VLANs. Obviously, the configurations were not applied, but you can use the show pending. Okay, and this is the new configuration. The region name, revision 1, 2 instance configured, the 0, and the number 1. The instance number 1 including VLAN 99 and 100. This is the new instance number 1. These configurations will be applied after you exit from this. Okay, exit to apply the changes and verify. Show spanning tree MST configuration. Okay, success. All changes applied. Configure on DLS2. Configure terminal spanning tree MST configuration. The region name, the revision 1. Create the new instance number 1 and include VLANs 99 and 100. Show the pending configuration to verify. Region name, CCNP, revision 1, 2 instance configured. Instance 0, including all VLANs except 99 and 100, and instance number 1, including VLAN 99 and 100. Exit to apply and verify. Show spanning tree MST configuration. Success. Wait a moment to let the topology settle, then issue the show spanning tree MST command on DLS1. For example, on DLS1, show spanning tree MST. Now you have two instances, MST0 and MST1. MST0 includes all VLANs except 99 and 100. The local bridge base MAC address is this. The priority by default is 32,768 plus the extended system ID. The instance number 0 is the result 32,768. This switch is the root for instance 0, and all ports in role designated and status forwarding, because this switch is the root. Instance number 1, VLAN 99 and 100, base MAC address for the local bridge, this, and the priority, the for priority 32,768 plus the instance extended system ID number 1 is 32,769. This switches the root for the instance number 1, and all ports are designated ports in forwarding state because this switch is the root. As you can see from the output above, the VLANs are mapped to the correct instance. Notice the type entry peer-to-peer bond very belong spanning tree. This entry shown when the device connected at the other end of the given interface is not running MST. In this case, ALS1 and ALS2 are running the default per VLAN spanning tree. Okay, for example, look at this. Gigabit 01 and 02, gigabit 01 and 02 for DLS1, the type peer-to-peer bound per VLAN spanning tree. In the other end of the link, that means that ALS1 is running per VLAN spanning tree. But look at here, gigabit 11 and 12, gigabit 11 and 12 for DLS1 only shows peer-to-peer because DLS2 is also using MST. Propagate MST configuration with BTP. Manual configuration of MST is not particularly difficult until the network scales to a large size. For switches to form a single MST region, they must match in all region parameters: region name, configuration revision, VLAN to instance mappings. Switches that differ in their MST region configuration will form separate regions, each region having its own internal root bridges for the defined MST instances and independent internal topologies. While having multiple regions is not an error per se, and some large networks are even partitioned into the multiple regions intentionally, running multiple MST regions as a result of region misconfiguration is undesirable. BTP version 3 allows for the sharing of the MST database among switches, which simplifies the process considerably. To use BTP version 3 to propagate the MST region configuration to all switches in the BTP domain, convert all switches to BTP version 3 and set them as servers or clients for MST. Then designate one switch as the BTP primary for MST. Do not forget to activate MST on all switches. BTP version 3 will synchronize only the region configuration across all switches and will not affect the STP version running on the switch. For example, on DLS1, verify short spanning tree MST. For instance number 0, this switch is the root DLS1, and for instance number 1, this switch is the root. On DLS2, verify show spanning tree MST. For instance number 0, the local bridge, the base MAC address is this, but the root base MAC address is this, the MAC address of DLS1, and the root port is gigabit 11. This interface to reach the root DLS1. For instance number 1, also DLS1 is the root. Okay, you can configure the BTP primary MST on DLS2 to propagate the MST configuration, and not problem with that. Okay, but I prefer to configure DLS1 for the BTP primary MST to propagate the MST configuration to all other switches because this switch is the root for the instance number 0 and also is the root for instance number 1. Okay, so instead I configured the BTP primary MST on DLS2, I will configure on DLS1. But remember this, convert all switches to BTP version 3. Okay, all switches to BTP version 3. DLS1, configure terminal BTP version 3. Configure terminal BTP version 3. Also ILS1, configure terminal BTP version 3. ILS2, configure terminal BTP version 3. Okay, and set them as servers or clients for MST. Do not forget to activate MST on all switches. DLS1 already configured with MST, so you need to configure the BTP mode server for MST. BTP mode server for MST. Also on DLS2, BTP mode server for MST. Okay, ILS1 is not configured with the spanning tree MST. So before to configure the BTP mode server for MST, configure the spanning tree mode to MST. Okay, spanning tree mode MST. And then set the BTP mode server for MST. The same way on LS2, spanning tree mode MST and BTP mode server for MST. Finally, designate one switch as the BTP primary for MST. Okay, I said that DLS1 will be the BTP primary for MST, and to go to privilege exit modes and set the BTP primary for MST. Okay, the system is becoming primary server for feature MST. No conflicting BTP3 devices found. Confirm, enter. An identical MST region configuration will be propagated to all switches within a BTP version 3 domain. And consequently, they will all form a single region. Okay, verify. ILS1 and show spanning tree MST configuration. Okay, the name revision to instances ILS2 and show spanning tree configuration, MST configuration. Okay, region revision to instances 0 and 1. DLS2 already configured with MST. Okay, ILS1 again, show spanning tree MST. instance number 0, all VLANs except 99 and 100. The local bridge base MAC address is this. The root base MAC address is another this, and DLS1 base MAC address. The bridge ID, priority, extended system ID, the instance number 0, root port gigabit 01 on ALS1 to reach the root. Okay, gigabit 01 is the root port forwarding state. Okay, peer-to-peer instance number 1, including 99 and 100 VLANs. Local bridge ID, local base MAC, local bridge base MAC address, bridge ID, priority plus the extended system ID, the instance number 1, plus the default priority is this 32,769. The root base MAC address, the root port gigabit 01, okay, gigabit 01, ILS2, show spanning tree MST, okay, instance 0, the root port is gigabit 03, this to reach the root, instance number 1, root port. Modify MST configuration. To further illustrate the convenience of MST and BTP version 3, add another instance on DLS2. In my case, DLS1, that is the BTP primary for MST. Mapping VLANs 110 and 120 to it. Okay, go to DLS1, the BTP primary for MST. Configure terminal, spanning tree MST configuration. Okay, create a new instance number 2 and add VLANs 110 and 120. Show pending to verify. And you will have another instance, and will be 3 instances configured. Exit to apply, exit, and show spanning tree MST configuration. Success. Verify, for example, on DLS2 and show spanning tree MST configuration. Okay, 3 instances, show spanning tree MST. This is the new instance number 2. For example, an ALS2, show a spanning tree configuration. Okay, show spanning tree MST. This is the new instance. Manipulate the spanning tree. To this point, we have left election of the root bridge up to the protocol defaults, which are the same as per VLAN spanning tree, with one exception. Port cost values are still based on the physical interfaces, but wide. Use much larger numbers. Okay, port cost which are assumed to find path cost is the cost for a root bridge, are different in MST. 10 megabits per second, 2 million, 100 megabits, 200 to 1000, 1 gigabit, 20,000, and 10 gigabit, 2000. Okay, for example, in my case, verify on DLS1, show a spanning tree MST. For instance number 0, the cost is 20,000 because I'm using gigabit interfaces. Okay, 20,000. MST uses the same basic commands and values to manipulate its operation. To manually configure the bridge to the primary MST route, use the command spanning tree MST instance list root primary or secondary global configuration command. You can also manually set the bridge priority using the spanning tree MST instance list priority and the priority number on global configuration command. In the example below, DLS1 is configured as the primary route for instance 0 and 1 and the secondary route for instance number 2. Okay, configure this on DLS1. Configure terminal. Spanning tree MST instance 0 and 1 root primary. But for instance number 2 root secondary. And DLS2 is configured with a complementary set of instructions, root primary for instance 2 and root secondary for 0 and 1. DLS2 configure terminal spanning tree MST for 0 and 1 root secondary. If for number 2 primary. And the result of these configuration changes are evident using the show spanning tree root command. Okay, for example, on ALS1, show spanning tree root. Okay, for instance number 0, the root port is gigabit 01. This. Okay, the root port is gigabit 01 for instance number 0. 01 on ALS1 to read the root for instance 0. For instance number 1, the root port is also gigabit 01 to reach the root, DLS1. But for instance number 2, the root port is gigabit 03. 03 on ALS1 to reach the root for instance number 2, that is DLS2. Or you can simply show spanning tree MST for MST, the root port gigabit 01, root port gigabit 01. For instance number 1, root port gigabit 01, 01, the root port, but for instance number 2, the root port is gigabit 03. This. Okay. As with per VLAN spanning tree, root port selection is based on total path cost to the root bridge. Path cost is the sum of port costs. You can configure the port cost using the spanning tree MST instance cost and the value interface configuration command, which sets the cost for that instance alone. As an implementation example, we will shut down interfaces 9 and 10 on DLS2 and then change the port cost values of ILS2 interface 7 to a lower number, causing the spanning tree for instance 2 to go through ILS2. Okay, first of all, verify this. Okay, on ALS1, show a spanning tree MST, go to instance number 2, and the root port is gigabit 03. This to reach the root switch for MST is DLS2, for instance number 2, DLS2 is the root. I will change the network to intentionally go from ALS1 through ALS2 and finally DLS2, and not go directly from ALS1 to DLS2. Okay. Shut down interfaces 9 and 10 on DLS2. In my case, on DLS2, gigabit 03 and 10, 03 and 10. Okay, go to DLS2, configure terminal, interface range, gigabit 03 and gigabit 10, shut down. Okay, verify on ALS1, show a spanning tree MST, okay, for the instance number 2, the root port now is gigabit 01. This interface on ALS1, so ALS1 will reach the root switch for instance number 2 through DLS1. Okay, but I want to ALS1 go to ALS2 and then go to DLS2. Also verify using the show spanning tree root. For instance number 2, the root port is gigabit 01. This in the root cost is 40,000. Okay. Okay. Okay, 40,000. 20,000 plus 20,000 is 40,000. To reach from to go from ALS1 to DLS2 through DLS1. Okay, there is another way to reach DLS2 is from ALS1 through ALS2 and finally DLS2, the route for instance number 2. The path cost is 20,000 plus 20,000, that is also 40,000. But gigabit 01 is preferred because DLS1 has a lower base MAC address, than ALS2. Okay, DLS1 show spanning tree MST. Okay, this local bridge base MAC address on DLS1 is lower than show spanning tree MST. Okay, base MAC address on DLS1 is a lower number than this. Is a lower number than this number, the base MAC address on ALS2. So that's why ALS1 prefers the path through DLS1 than ALS2. Now, I will change the costs on gigabit 01 on LAS2, and also gigabit 01 is preferred than gigabit 02 because gigabit 01 has a lower number than gigabit 02. Okay, DLS1, gigabit 01 has a lower number than gigabit 02. Okay, go to ALS1. Show a spanning tree MST. Gigabit 01 has a lower number than gigabit 02. Okay, a lower number on gigabit 01 than gigabit 02. Okay, and so that's why ALS1 preferred to reach DLS2 through DLS1 using gigabit 01. Okay, and I will modify and review the ALS2. Show spanning tree MST. For instance number 2, gigabit 01 is the route with the cost 20,000. Okay, 20,000 cost to reach from ALS2 to the route DLS2. I will change this cost on gigabit 01 to 10,000. Configure terminal interface gigabit 01 spanning tree MST. Instance number 2 costs 10,000. Exit and verify. Show spanning tree MST. For instance number 2, 10,000 gigabit 01. Okay, and now change to 10,000. Okay, and look at this. For instance number 1, the cost is still 20,000 for gigabit 01. And for instance number 0, the cost for gigabit 01 is still 20,000. Okay, the change was made only for instance number 2. That's why it's called multiple spanning tree. Okay, and this path will be preferred from ALS1 through LAS2 to reach DLS2 will be preferred. Verify that on ALS1, show a spanning tree MST. For instance number 2, now the root port is gigabit 11. Okay, this interface now is preferred. Okay, the cost on gigabit 11 is still 20,000 because the change was made on gigabit 01 on ALS2. Okay, and show a spanning tree root. Okay, for instance number 2, gigabit 11, the root port. Look at this, the root cost is 30,000. 20,000 plus 10,000 is 30,000. Is preferred than 20,000 plus 20,000, that is 40,000. End of lab, use the TCL script reset.tcl created in lab 1 to create and reload all of your switches before the next lab. Thank you very much.